Hi girls, in this video I'm just going to go through a little bit of 9G gradient intercept form, but I'm making the assumption that you've done as I asked, and that was to work through the self-directed task, and that was on gradient intercept form and also some of 9F. So hopefully you are noticing in that we first, we have a line which is in this equation, y equals mx plus c. This here is the gradient. Okay, and the c here is actually, well, the y-intercept's when x equals 0. So if x was to equal 0, that would get rid of that. 0 times anything, 0. And we're just left with c. So this is the y-intercept when x equals 0, because we've just got y is equal to c. So that is the y-intercept. So I just wanted to go through just a couple of things, and this is going to help you do your coursework today. So I want you to be able to watch this video and then try similar questions in 9G, which sort of combines gradient and the straight line graphs. So when we're asked for the gradient and the y-intercept, just remember that the coefficient of x is the gradient. Okay, so you can get it straight from the equation. And here we have the y-intercept. Likewise, a gradient can be a whole number. It can also be a fraction. So what does it mean? Well, the gradient is equal to the rise over the run. If I've got a fraction of a third, it rises 1 and it goes across 3. So there you go. There's the gradient, which we can also write as m is 1/3. Again, the coefficient of x. What does a 1/3 gradient mean? Well, it means that instead, if I had a gradient of 3, it would go across 1 and up 3. Well, if I had a gradient of a third, it goes across 3 and up 1. So it's obviously just not going to be as steep. So this might be the gradient. This might have a gradient of 1/3, and 3 goes across 1 up 3 might sort of go something like that. It's much steeper. Okay, so still positive. It's still going from left to right. It's working its way up. But as you can see, the higher this gradient is, the steeper it is. Now let's have a look at. This is where, of course, it can be a bit tricky because we've got to find the rules. So we've got to find the equation in terms of y equals mx plus c. So if we have a look, we can't see the gradient straight away, but what we can see is we can see that this is the y-intercept. Okay, so the y-intercept is equal to -1. Now let's work out the gradient. If I go across 1, I go up 1, 2, 3, 4. So the gradient is 4. Now if I've got the y-intercept and I've got the gradient, then I can find the equation of the line. Finding m and finding c. Well, we found m is 4, so that would be the coefficient of x, 4x. We know it's also positive because it's going from left to right, it's working its way up. And of course, the y-intercept plus c goes there. Now over here, we notice it's going from left to right, it's working its way down. So we've got a negative gradient. But let's work our way across. If I go across, it's working its way down. But notice I go from there to there, I go across 2. So we could also write the gradient as the rise over the run. Now you can see there, I've just gone across 2. So the run would be 2. Now the rise, we can have positive or negative rise. If it's going up, it's going to be positive. It's going down. So notice that we go down 4. Okay, so down 4 would be that. We know that 2 goes into 4 2 times, and a negative divided by positive is a negative. So we've got our gradient there, and which is -2. And now you notice that we've got the y-intercept. Okay, the y-intercept happens to be, if I've got y is equal to mx plus c, that there is the y-intercept. So let's put together what we have. -2 is the gradient, that's the coefficient of x, and then plus 4. Okay, so now can I get you to, based on just what we've done, see if you can try these now. Pause this now. have a go at these ones, and I'll go through them in a second. All right, so hopefully you've had a try at this. Again, we need to find m, and we need to find the constant c. This is the y-intercept. This is the gradient. Okay, so the easy one's usually the y-intercept. We can see there it crosses the y-axis at -3. So we can say that the y-intercept is -3. So therefore we can say that c is equal to -3. And let's work out the gradient. Now I go across 1, I go up. Look, how many am I going up? I'm going up 2, aren't I? Go across 1, I'm going up 1, 2. So that means that our gradient is equal to 2. So if I've got the gradient and I've got the y-intercept, I can actually find the equation. Y is equal to, put the gradient in front of x, and the y-intercept goes there. Over here, we know that the y-intercept is 6, and the gradient, well, we know it's going to be negative, but let's do it as the rise over the run. Now the rise, it's negative rise, it's going down. So let's just say we don't have to go in once. Okay, we can. But if I go down 6 and the run, it goes across 2, we can use that as well. Okay, so yes, we do go down 3 and across 1, but 6 divided by 2 is 3, and negative divided by positive is a negative. So that's going to be -3. Now just bring it all together. Y is equal to -3x plus 6. Okay, so you're going to have similar questions like this. So in 9, if I was to go and show you the 9G coursework, then you're looking at questions which are, first of all, you've got the first question or two, which will be asking you to find the gradient intercept. So this here, the gradient is equal to 1/2, and the y-intercept is equal to the constant with the sign, -3, doing it like so. You'll then have to, question 3 is a really good practice. So I would suggest, starting off with question 1, then working your way to question 3, where you've got to find the rules. Again, you've got the y-intercept, and you can work your way across 1 up, and then you can find the gradient from there. Okay, so there's sort of like question 3. Now, you've also got horizontal lines. Remember that, again, we can use this y is equal to mx plus c. But notice here, if I've got a line here, notice it goes across, but it never goes up. So we can say here that the rise is 0. And the run, it doesn't matter what the run is, 0 divided by anything is 0. So we've got 0x, and then notice here that the c is the y-intercept. It crosses the y-axis at -3. So we've got 0x minus 3, and of course 0x is just 0, so we don't need that. It's just y equals -3. So y equals -3 is a horizontal line with a 0 gradient. Likewise, if I see something like this, a little bit different because the gradient, hopefully you recognized, well, the rise is infinite. Okay, we've got 0 run. If I try to do anything divided by 0, you're going to get an error in your calculator. There's no gradient. It's what we call undefined. So the gradient is undefined. What we can say with this one, though, is that all of the x values are 7. Okay, so it's simply just x is equal to 7 is this vertical line. And finally, of course, we've got finding the equations of a line given 2 points. These are quite tricky because we don't really have a graph to work our way across and up and find the rise. But there is this other expression, which is rise over run. Okay, but rise over run is, well, the rise is how much the difference between the two y coordinates. So what we can say is it's also this, y2 minus y1. And the run is the difference between the two x coordinates, which is x2 minus x1. Okay, you definitely want to practice a lot before you get to here, but we can indeed use this rule here. So what we've got to do is let's label if this is the first one, we'll call this x1 and has a y coordinate y1. And let's have over here, we've got this is x2 and this is y2. So now what we can do is, well, this is x1, this is y1. Let's throw those into our rule, which is this here, rise over run. Now the rise is y2 subtract y1. The difference of the two coordinates is going to give you the rise, and likewise for the run for x. So let's do that. Y2 is 5. So we've got 5. And then we've got take away y1, which is 1. x2 is 1. And y1, we're subtracting -1. Now 5 take 1 is 4, but of course, what's this going to be? 1 subtract -1. Remember that negative becomes a positive, so it's the same as 1 plus 1, which is 2. So that gives us a gradient of 2. I guess the trick with these, though, is you don't have the y-intercepts, but what we do know is we do know what m is. Okay, y is equal to mx plus c. M is 2, okay, so we've got 2x plus c, and what we could do is if we needed to find c, although we don't have the y-intercept, we can find it by just substituting any of these points in to find the unknown. So we could say, okay, well, what does this mean? It means that when x equals -1, y is equal to 1, that is a point on the line. So if I throw that in, well, there's a y is 1, and 2 times -1 plus c, like so. And then we just have to solve it. 2 times -1 is -2, and we then add 2 to both sides. Add 2 to both sides is going to be 3 is equal to c. So there you go. If c is 3, then therefore we can say that our equation is y is equal to 2x plus 3, and of course that there would be the y-intercept. That's obviously much more advanced, that question, than the earlier one. So what I'm going to suggest is obviously work your way for question 1, then question 3, then have a go at something else, and then of course you'll need to work your way up to that. I'd say that as far as this whole topic goes, this something like question 9 would really be as hard as it gets as finding equations of a line. So don't be too worried if you're struggling with that concept now. But we need to find those two unknowns, and this here is another rule for finding the gradient. All right, I'm going to stop you there. Hopefully you can use this video to have a go and finish off some of the questions from 9G. And we'll have just your standard theory class next class. All right, thanks, girls. Take care, and I'll see you soon.